Hello, I'm very happy to be given a chance to interact with you all. Let me first introduce myself. I'm Professor Ranjana Prakash from Physics Department, University of Allahabad, Allahabad. I shall be putting forward some views on why so few women in STEM workforce. Now, first of all, to find out what STEM fields stand for. STEM is an acronym for Science, Technology, Engineering and Mathematics. Now, let us understand what is the meaning of underrepresentation of women in STEM. Proportion of females in STEM fields is less than their proportion in the population or the relevant demographic segment of the population. Proportion of women is close to 50%. About 51% of naturally occurring births are male, but females have higher survival rates through childhood. As a reasonable rule of the thumb, if proportion of females in a given STEM field is much less than half, women would be called underrepresented in that field. Why underrepresentation should be a problem? If many women with potential to excel in STEM fields fail at entry levels because of discrimination or stereotype projections, it is a huge collective loss. Each group brings its own understanding and perspective of the subject. Lower representation of one group leads to an underrepresentation of a particular perspective, and it derails the progress of the subject. Groups with different experiences have different approaches, and inclusion of women in STEM might add a new dimension in applications of ideas in science to creativity and growth of science. Underrepresentation of women is not just a problem for women, but it is a problem for the society at large. Contribution of females, 50% of the population, cannot be ignored. Early school upbringing and home atmosphere creates gender bias. Different early stage experiences of boys and girls. Girls are projected as help givers, taught to seek help and guidance rather than to be self-reliant. Boys are taught to be inquisitive and independent. Boys encouraged to explore the physical world, finding out how things work, do problem solving, assembling toy planes, solving jigsaw puzzles. Girls' activities center on relation-based and caregiving activities. In primary schools, parents have lower expectations for their daughters in maths and science. Girls' achievements are attributed to their conscientiousness and hard work, while boys' skills are attributed to innate talent. Mothers apply gender stereotypes about STEM more than fathers. Notion persists that boys are smart and curious and girls are hardworking and conscientious. Girls' decisions to pursue STEM subjects and take advanced classes are often influenced by how well their female friends performed earlier. Causes of underrepresentation of females in higher education. Although the number of women in science and engineering is growing, yet men continue to outnumber women, especially in the upper echelons of professions in STEM. In elementary, middle and high school, girls and boys opt for maths and science in roughly equal numbers. By graduation, men outnumber women in nearly every science and engineering field. In some fields such as physics, engineering and computer science, the difference is dramatic. This decline in the transition to workplace is also very striking. Various factors may be responsible for this disparity, and the existing gender gap in STEM may be ascribed to various reasons. I will now try to list and explain the various factors influencing the gender gap. Girls' achievements and interest in maths and science are shaped by the environment around them. The question often asked by researchers and educators during studies on gender gap in STEM is, does the stereotype that boys are better than girls in maths and science still affect the girls today? Research reports emphasize the negative stereotypes about girls' capabilities in maths and science indeed measurably lower girls' test performance. Researchers also believe that stereotypes can lower girls' test performance and aspirations for science and engineering careers over time. It must be noted that even though a relation exists between high math scores and entry into STEM education and careers, very high math scores are not necessarily a prerequisite for success in STEM fields. There must be other factors which contribute to the gender gap in STEM fields. Even girls and women who excel in mathematics often do not pursue STEM. In studies of high mathematic achievers, women more often are likely to secure degrees in humanities, life sciences, and social sciences rather than in maths, physics, or computer science. It is very true that girls assess their mathematical ability lower than do boys with equivalent scores in maths. Often because of this, girls are likely to believe that they will succeed in a STEM field and hence likely to evince interest in a STEM career. Various findings show that when teachers and parents tell girls that their intelligence can grow with learning and experience, girls perform much better. In other words, believing in the potential for intellectual growth in itself improves the outcome. By creating a growth mindset, teachers and parents can encourage girls' interest in achievements in STEM fields. Theories for gender mismatch in STEM. Two theories have been propounded to explain the gender mismatch in STEM. The first theory is called the leaky pipeline theory. As they move up the science career ladder, women drop out disproportionately at every step, an effect known as the leaky pipeline. The path from elementary school to a STEM career has often been compared to a pipeline. This metaphor suggests that as the number of girls who study STEM subjects in elementary, middle, and secondary school increases, more girls go into the pipeline. The number of women who become scientists and engineers will also increase, more women coming out of the pipeline. This has not really happened at the expected rate, and hence, especially in STEM, we say that there is a leaky pipeline. Gender bias in science. The second theory propounded is known as the greater male variance theory. Underrepresentation of women in the top levels of academia is due to different availability of aptitude at the high end. Suppose the distribution of aptitude as measured, for example, by the IQ or SAT scores among men fits a bell curve with a mean mu m and variation sigma m, and the distribution of the same aptitude among women fits a different bell curve with mean mu w and variation sigma w. Then one can imagine a world in which the means of each distribution are equal, but the widths of the distributions are very different. If the bell curve for men is flatter than that of women, then this hypothetical world would have more of both very low performing men and very high performing men than the equivalent of women. This situation might, for example, explain why many more men than women become scientists. This idea is called the greater male variance theory, and it would imply that the gaping gender disparity in the sciences is the expected consequence of natural variation in aptitude and ability among men and women. Cognitive gender differences. Studies of Lin and Irving found small or no difference in average IQ between the sexes. That is, neither boys nor girls are the smarter sex. Others found that girls and boys have different cognitive strengths and weaknesses, and claimed that generally boys perform better on tasks which use spatial orientation and visualization skills, and quantitative tasks that use those skills. Girls outperform boys in tests relying on verbal skills, writing skills, on tests involving memory and perceptual speed. One of the largest gender gaps in cognitive skills is seen in the area of spatial skills, with boys outscoring girls. However, the connection between well-developed spatial skills and success in science and engineering careers is not well defined. Courses can be designed and implemented to improve spatial visualization skills. Some argue on the basis of hormonal differences. Evidence for a hormonal basis for the dearth of female scientists is weaker than the evidence of other factors. The other factors could be the socio-cultural influences on girls' performance. Eileen Pollock studied difference in gender gap in science and math fields cross-culturally and role of socio-cultural factors. In most of the countries, more boys than girls scored above the 99th percentile in maths, but in Thailand and Iceland, more girls than boys scored above the 99th percentile. This illustrates the importance of culture and development of mathematical skills. It was also noted that boys outnumber girls at the very high end of the maths test score distribution. In the study of STEM professionals in the private sector, Hewlett et al. Found that many women complained of an unsupportive work environment, extreme work schedules, and unclear rules about advancement and success as major factors in their decision to leave. Academia is somewhat different. In a recent study on attrition among STEM faculty, ZU showed that female faculty is mainly dissatisfied with departmental culture, advancement opportunities, faculty leadership, and research support. Other reasons for a low percentage of women in STEM can be workplace environment, bias, and family responsibility. Workplace environment. In the study of STEM professionals in the private sector, Hewlett et al. Found that many women complained of an unsupportive work environment, extreme work schedules, unclear rules about advancement and success as major factors responsible for the decisions to leave. The situation in academia is somewhat different. ZU showed dissatisfaction with departmental culture, lack of interaction with senior faculty, and lack of mentoring for research support as some of the reasons for women to leave. Women cited feelings of isolation even in a supportive work environment because of their low numbers. Bias is another reason. Women in STEM fields often experience bias that negatively influences their progress and participation. It is true that instances of explicit bias may be decreasing with time, but implicit bias does continue to have an adverse effect. Implicit biases may be stronger than explicitly held beliefs of values. Even individuals who profess strong beliefs of gender equality may harbor implicit biases about gender. Hence, negative gender stereotypes about women and girls in science and maths. They will still persist. Many studies found that majority of both women and men of racial ethnic groups hold a strong implicit association of male gender with science and female gender with arts. Many people say they do not believe the stereotype that girls and women are not as good as boys and men in maths and science. The research of Banerjee shows that even individuals who consciously refuse gender stereotypes can still hold that belief at an unconscious level. These unconscious beliefs or implicit biases may be more powerful than explicitly held beliefs and values because we are really not aware of them. Even if gender bias is waning, research shows that less conscious beliefs underlying negative stereotypes continue to influence assumptions about people and their behavior. In fact, all programs promoting equal opportunity seek the removal of external constraints. Yet, until the internal mental constraints that link group identify with preferences are removed, it will be difficult to address gender gap. Research has also pointed to bias in peer reviews and hiring. That was Wemras and Wold, Trim and Pisenka. Quoting the above two references, a female postdoctoral applicant had to be significantly more productive than a male applicant to receive the same peer review scores. This means that she has to publish more papers in prestigious science journals. The systematic underrating of female applicants could help to explain the lower success rate of female scientists in achieving high academic rank compared to their male counterparts. Trim and Pisenka found systematic differences in letters of recommendation for academic faculty positions for female and male applicants. Recommendation letters written for women are more likely to refer to their compassion, teaching and efforts as opposed to their achievements, research and ability, which are characteristics highlighted for male applicants. Understandably, nothing is wrong with being compassionate, being a good teacher, trying and working hard. However, these traits are less valued than achievements and ability to do research, which would spell success for the male faculty. Hence, a foregone conclusion. Recommenders unknowingly use selective categorization and perception in choosing what features to include in the profile of the female applicants. A very recent study published by Eileen Pollack, 2013, reports that researchers at Yale showed that physicists, chemists, and biologists are likely to view a young male scientist more favorably than a woman with the same qualifications. Presented with identical summaries of the accomplishment of two imaginary applicants, preferences at 6 major institutions were significantly more willing to offer the man a job, rated the male applicant as significantly more competent and hireable than identical female applicant. Surprisingly, female scientists were as biased as their male counterparts. The new study goes a long way towards providing hard evidence of continuing bias against women in science. The double bind, being competent and well-liked. Being competent and well-liked are important for advancement in the workplace. This balance is more difficult to achieve for women than men in STEM. Heinemann performed a number of experiments which proved that in terms of likability, when performance was unclear, participants voted the female employee as more likable. But when success was clear, participants overwhelmingly indicated that the man was more likable than the woman, with 19 out of 25 choosing to vote the successful man as more likable than the successful woman. The most critical point from this research, Heinemann, is whereas there are many things that lead to an individual to be disliked, qualities like obnoxious behavior, arrogance, stubbornness, it is only women, not men, for whom a unique property towards dislike is created. By what? By success in a non-traditional work situation. This suggests that success can create an additional impediment to women's upward mobility in male-dominated fields, even when they have done all the right things to move ahead in their careers. Being disliked appears to have clear consequences for evaluation and recommendation about reward allocation. Indiana University has studied stress levels of women working in highly male-dominated occupations. They wanted to know how it affected cortisol, the stress hormone that regulates the changes in our bodies such as blood sugar levels, metabolism and immunity to illness that occurs due to stress. Token women, those working in a predominantly male environment, were observed to display less healthy patterns of cortisol throughout the day due to negative working conditions. Imposter syndrome. Imposter syndrome describes a situation where someone feels like an imposter or fraud because they think that they have duped people in believing that their accomplishments are of high caliber. Usually their accomplishments are of a high caliber, but the person is applying unfairly high standard to himself or herself and not to others. This is especially common in fields where people's work is constantly under review by talented peers, such as the academia. Women experiencing imposter syndrome may be less willing to put themselves forward, feeling that they are not qualified enough. They may not submit papers disclaiming or underrating their skills. They may not even apply for promotions. Research suggests that women find it harder to trumpet their own accomplishments. Men are better at networking and selling themselves. It is not that women are inherently lacking the ability to self-promote, but stereotype violation bars them from doing so. Women hence face a double bind. They are penalized socially in behaving in ways that might be perceived as immodest, and they are penalized professionally for behaving in a way that are not self-promoting. Suggestions to managers and recruiters: to reach these managers, to teach them to reach out to women in addition to making a general advertisement for a job. Avoid using the terms "please rate your experiences and skills" questions during early recruitment phases. Recruiters must encourage women to accept opportunities and challenges they are qualified. Only when they are successful in bridging this gender gap, when they will address the women faculty. Family responsibility. Both men and women identify family as a possible barrier to advancement, but women are affected differently than men by this family penalty. This was pointed out by Sigmund et al. In 2008. Although both women and men feel that having a family hinders their success at work, women are more likely than men to report foregoing marriage or children or delaying having children. Women report that they are the primary caregivers. Other family issues involving partnership, work full-time, cannot assist them to do their daily chores. Additionally, some female STEM workers may have spouses who are also in STEM and face similar demanding work schedules. In a situation where a two-body problem exists, the man's career is often given priority. Hewlett et al. Next factor might be the gender pay gap in STEM. In most academic institutions, men and women receive the same pay. Differences in salary in industry jobs in science and engineering may be due to the nature of the job and their experience. Statistics of US women in science: American women shun STEM. If we are asked a question, which countries' universities are more likely to attract high-flying women in these STEM fields? If you answered those in the US, think again. Just 4% of US women identified as high performers study STEM subjects. In India, 57% of high performing women study STEM subjects. In Morocco, it's 37, Turkey 25, Brazil, Germany, Mexico, Saudi Arabia and the United Kingdom still have rates higher than the United States. American women may see reasonable economic opportunities in a wide array of non-STEM fields, such as business or nursing or law. They may also be more confident that they can study the liberal arts and still get good jobs. In US, employers have a major role to play. Women STEM graduates are 25% more likely than male ones to be unemployed. Also, they receive much less on the training than their male counterparts do. Smart, ambitious young women in lesser developed countries and lesser developed economies like India, by contrast, may prefer to concentrate on pathways that present a better understood future. That means majoring in STEM instead of, say, literature. Asian women in STEM careers: very small numbers of Asian women scientists and engineers are advancing to become full professors or deans of university, presidents in academia, to serve on corporate board of trustees or become managers in industry, or to reach managerial positions in government. In academia, 80% of this population can be found in non-faculty positions, such as postdocs, researchers, lab assistants, or non-tenured faculty positions. 95% employed in industry and over 70% employed in government are in non-managerial positions. Women scientists in India. In India, the situation of women in science is very similar to other Asian countries. Indian women have progressed and come a long way in terms of science education. Women form 40% of the undergraduates in science. Out of the total PhDs in India, 25 to 30% are women. In India, the real attrition begins after the PhD. Out of the 25-30% PhDs, the women who occupy faculty positions is between 15 to 20. As one reaches the higher strata, the number of female faculty diminish drastically. It is rare to find female head of the laboratories, science departments of the governments, or as members of the governing or advisory bodies. The inability of women to balance a family and career is the main reason cited for this huge gender gap. This inability to balance family and career may be ascribed to the inherent assumption in India that family and family welfare is the sole responsibility of women. In 1995, when the Fourth World Conference was held in Beijing, discussions mainly focused on empowerment of women through science and technology. Triggered by these recommendations, serious note of science as a career choice for women was taken up by the Indian National Science Academy. A task force was formed in science and technology, which recommended various measures to attract, increase and retain participation of women in science. In India, although no such belief exists that women are not capable of doing science and engineering, but still the participation of women in these fields is small. There is significant participation of women studying science as well as teaching science in schools at undergraduate colleges. The percentage of women faculty and students in science and engineering decreases with the repute of the institution involved. In IITs and IIMs, the fiercely competitive nature of admission process requires time, guidance and above all, money for preparation. Parents on an average are not ready to invest such huge amounts on the girl child. The number of women on the faculty in research institutions is not commensurate with the fraction of PhDs earned. This is especially true for the so-called institutes of repute like TIFRs and IITs and IISc. When one considers the top administrative or leadership positions such as directors and members of advisory boards, the women are nowhere. Data studies show that the percentage of women faculty in pure engineering departments is small. In the universities, the percentage of women faculty improves because of diverse disciplines. The situation might be better in some newer institutions like IISers. An interesting study shows that the proportion of women scientists who never married is higher than the male scientists who never married. The number of women scientists married to male scientists is appreciable. Given the fact that the fraction of women among scientists is small, women will be scarce in top positions. The small fraction of women faculty and scientists is also reflected in the small number of scientists as principal investigators. A gaping gender disparity in the topmost scientific award given to scientists below the age of 45 in India, the Shanti Swarup Bhatnagar Award. Out of 461 awards given so far, only 15 have gone to women. 4 in medicine, medicinal science, 2 in mathematics, none in physics, 3 in chemistry, 2 in engineering, 3 in biology and 4 in earth sciences. Indian women are thus highly unrepresented at the highest levels of academic recognition and honor. Only about 1/4 of STEM workers are females. Within disciplines, there are variations. Female participants in biological subjects as medical and life sciences is high and above 50% in some countries. But in physics, computer science and engineering, it is less than 30% in most countries. The good news is that there is an increasing number of women receiving education in science in India. Working in science has not been easy for women with its long hours of work, societal biases and the need to balance family and career. The most talked about images from India's Mars orbiter mission MOM was that of a women scientist celebrating the success of the mission. The image of sari-clad, flower-adorned ladies gave most STEM female scientists an immense warm feeling, a precursor of better things to come. Thank you.